Question 1. The monitoring system demonstrates the collection of detailed performance metrics and user activity logs across the virtualized data center. Given the regulatory framework for data protection and privacy, which of the following approaches to managing this monitoring data best aligns with compliance requirements? Option A. Continue collecting all detailed user activity logs and performance metrics as provided by the monitoring vendor, assuming vendor compliance implicitly covers organizational obligations. Option B. Collect and retain all detailed user activity logs and performance metrics indefinitely, with the justification that comprehensive data is always beneficial for potential future investigations. Option C. Implement data anonymization and aggregation techniques for all user activity logs, retaining only essential performance metrics and anonymized operational data for security and troubleshooting purposes. Option D. Disable monitoring functions that generate excessive data or are perceived as resource-intensive, without a formal risk assessment or documented justification for the reduced visibility. Correct answer is C. Implement data anonymization and aggregation techniques for all user activity logs, retaining only essential performance metrics and anonymized operational data for security and troubleshooting purposes. Explanation. This scenario presents a professional challenge because it requires balancing the operational needs of a virtualized data center with stringent regulatory compliance requirements, specifically concerning data privacy and security. The challenge lies in interpreting and applying the relevant regulations to a dynamic and complex technical environment. Careful judgment is required to ensure that monitoring practices do not inadvertently violate privacy laws, while still providing the necessary visibility for security and performance management. The correct approach represents best professional practice because it prioritizes data minimization and anonymization in accordance with the principles of data protection regulations. By focusing on aggregated, anonymized data for performance and security monitoring, it adheres to the spirit and letter of regulations that mandate protecting individual privacy. This approach demonstrates a proactive understanding of compliance obligations, ensuring that the monitoring system serves its intended purpose without creating undue risk of data breaches or privacy violations. An incorrect approach that involves collecting and retaining detailed, identifiable user activity logs without a clear, documented business or legal justification fails to meet regulatory standards. Such a practice could be considered a violation of data privacy principles, potentially leading to significant legal and financial penalties. It demonstrates a lack of due diligence in assessing the necessity and proportionality of data collection. Another incorrect approach, which relies solely on vendor-provided default monitoring configurations without a thorough review against specific regulatory requirements, is professionally negligent. This oversight can lead to the collection of excessive or sensitive data that is not adequately protected or justified, thereby exposing the organization to compliance risks. It signifies a failure to implement a tailored compliance strategy. A further incorrect approach, which involves disabling certain monitoring functions deemed too noisy or resource-intensive without a formal risk assessment and documented exception, is also problematic. This action, if it results in a loss of visibility into potential security incidents or compliance deviations, can be seen as a failure to maintain adequate security controls, which is a common regulatory requirement. The professional reasoning process for similar situations should involve a multi-step approach. First, identify all applicable regulatory frameworks, e.g., GDPR, CCPA, HIPAA, depending on the jurisdiction and data types. Second, conduct a thorough data inventory and mapping exercise to understand what data is being collected, processed, and stored by the monitoring system. Third, perform a risk assessment to evaluate the potential privacy and security implications of the monitoring practices. Fourth, design and implement monitoring strategies that adhere to the principles of data minimization, purpose limitation, and security by design. Finally, establish a regular review and audit process to ensure ongoing compliance and adapt to evolving regulatory landscapes and technological changes. Question 2. Risk assessment procedures indicate a potential for unauthorized access to sensitive customer data stored within the virtualized data center environment. The organization operates under strict data privacy regulation that mandates specific controls for data at rest and in transit. Which of the following design approaches best addresses these regulatory requirements and mitigates the identified risk? Option A. Implementing robust encryption for all data at rest and in transit, coupled with strict access control policies enforced through multi-factor authentication and role-based access control RBAC for all virtual machine and storage resources. Option B. Implementing a single layer of encryption for data at rest, without addressing data in transit or granular access controls, to simplify management and reduce complexity. Option C. Deploying a basic firewall at the network perimeter and relying on default security settings for virtual machines, assuming that the cloud provider's infrastructure offers sufficient protection. Option D. Focusing primarily on performance optimization and cost savings, with minimal investment in advanced security features, as the likelihood of a breach is considered low. The correct answer is A. Implementing robust encryption for all data at rest and in transit, coupled with strict access control policies enforced through multi-factor authentication and role-based access control RBAC for all virtual machine and storage resources. Explanation. The scenario presents a common challenge in data center virtualization design, balancing the need for robust security and compliance with operational efficiency and cost. The challenge lies in interpreting and applying regulatory requirements to a technical design, ensuring that the chosen solutions not only meet but exceed compliance mandates without introducing unnecessary complexity or risk. Careful judgment is required to select the most appropriate controls that align with the specific regulatory framework governing the organization's operations. The correct approach represents best professional practice because it directly addresses the identified risk by implementing controls that are specifically mandated or recommended by relevant regulatory bodies for data protection and system integrity. This proactive stance ensures that the design is not only compliant, but also resilient against potential threats, thereby safeguarding sensitive data and maintaining business continuity. Adherence to established security frameworks and best practices, as often referenced in regulatory guidance, is paramount. An incorrect approach that focuses solely on cost reduction without a thorough risk assessment or consideration of regulatory impact is professionally unacceptable. This failure to prioritize compliance can lead to significant legal penalties, reputational damage, and data breaches. Another incorrect approach that relies on outdated or unverified security measures ignores the evolving threat landscape and regulatory expectations, creating vulnerabilities. Furthermore, an approach that over-engineers security without a clear risk-based justification can lead to operational inefficiencies and increased costs, which is also a failure in professional design. Professionals should employ a risk-based decision-making framework. This involves 1. Identifying and understanding all applicable regulatory requirements. 2. Conducting a comprehensive risk assessment to identify potential threats and vulnerabilities within the proposed design. 3. Evaluating potential solutions against both the identified risks and regulatory mandates. 4. Prioritizing controls based on their effectiveness in mitigating risks and achieving compliance. 5. Documenting the rationale for all design decisions, particularly those related to security and compliance, to demonstrate due diligence. Question 3. Quality control measures reveal that the primary network path for vCenter server management traffic is currently a single point of failure, with no immediate redundancy in place. While the probability of this specific link failing is assessed as low, the impact of such a failure would be the inability to manage the entire virtualized environment, potentially leading to significant operational disruption. Which of the following approaches best addresses this identified risk within the context of a robust data center virtualization design? Option A. Increase the frequency of manual backups for the vCenter server configuration to mitigate potential data loss. Option B. Propose a complete overhaul of the entire data center network infrastructure to ensure end-to-end redundancy for all traffic types. Option C. Implement a redundant network path specifically for vCenter server management traffic, ensuring failover capabilities. Option D. Document the risk and accept it, relying on existing operational procedures for recovery in the event of a failure. The correct answer is C. Implement a redundant network path specifically for vCenter server management traffic, ensuring failover capabilities. Explanation. This scenario presents a professional challenge because the identified risk, while seemingly minor in isolation, has the potential for cascading negative impacts on the availability and integrity of critical data center services. The challenge lies in balancing the cost and effort of mitigation against the probability and severity of the risk, all while adhering to the principles of robust data center design and operational best practices as outlined by VMware's professional standards for the 3V0-624 exam. Careful judgment is required to ensure that the chosen approach is both effective and efficient. The correct approach represents best professional practice because it directly addresses the identified risk with a proportionate and technically sound solution. Implementing a redundant network path for critical management traffic ensures that a single point of failure is eliminated, thereby enhancing the resilience and availability of the vCenter server and other essential management components. This aligns with the core tenets of data center virtualization design, which emphasize high availability, fault tolerance, and the protection of critical infrastructure. By proactively mitigating this risk, the design avoids potential service disruptions, data loss, and the associated reputational and financial damage, all of which are implicitly governed by the professional expectations of a VMware certified advanced professional. An incorrect approach that involves ignoring the risk due to perceived low probability fails to uphold the principle of due diligence in risk management. While the probability might be low, the impact of a management network failure could be catastrophic, leading to an inability to manage the virtual environment, potentially causing extended downtime. This oversight represents a failure to adequately protect the client's infrastructure and could be seen as a breach of professional responsibility to design for resilience. Another incorrect approach, such as relying solely on existing, non-redundant infrastructure and hoping for the best, demonstrates a lack of foresight and a disregard for established best practices in fault tolerance. This approach prioritizes cost savings over operational stability and risk mitigation, which is professionally unacceptable in a critical data center environment. It exposes the environment to unnecessary vulnerabilities. A further incorrect approach, like proposing an overly complex and expensive solution that far exceeds the actual risk, demonstrates poor judgment and a misunderstanding of proportionate risk management. While redundancy is important, the solution must be commensurate with the identified risk. Such an approach could lead to inefficient resource allocation and unnecessary operational overhead, failing to meet the practical design requirements of a professional solution. The professional reasoning process for similar situations should involve a structured risk assessment methodology. This includes identifying assets, threats, vulnerabilities, and potential impacts. Once risks are identified, they should be analyzed for their probability and severity. Mitigation strategies should then be developed, considering cost-effectiveness, technical feasibility, and alignment with overall design goals and professional standards. The decision-making process should prioritize solutions that enhance resilience, availability, and security while remaining practical and justifiable. Question 4. Operational review demonstrates that the proposed VMware 6.5 data center virtualization design requires a comprehensive risk assessment to ensure its security and resilience. Which approach to risk assessment is most appropriate for this design phase? Option A. Create a broad inventory of all possible technical vulnerabilities within the VMware ecosystem, regardless of their relevance to the specific design, and document each one for future reference. Option B. Conduct a detailed threat modeling exercise that identifies potential attack vectors and vulnerabilities specific to the chosen VMware 6.5 components, and then prioritize mitigation strategies based on the assessed likelihood and potential impact of each threat. Option C. Utilize a generic risk assessment framework that applies to any IT infrastructure, without specific consideration for the unique characteristics and configurations of the VMware 6.5 data center virtualization environment. Option D. Assign the entire risk assessment responsibility to an external security audit team, with minimal direct involvement from the virtualization design architects during the assessment process. The correct answer is B. Conduct a detailed threat modeling exercise that identifies potential attack vectors and vulnerabilities specific to the chosen VMware 6.5 components, and then prioritize mitigation strategies based on the assessed likelihood and potential impact of each threat. Explanation. This scenario presents a common challenge in data center virtualization design, balancing the need for robust risk assessment with the practical constraints of project timelines and resource allocation. The professional challenge lies in ensuring that the risk assessment process is thorough enough to identify and mitigate potential threats to the virtualized environment without becoming an insurmountable bottleneck. This requires a nuanced understanding of risk methodologies and their applicability within the VMware 6.5 data center virtualization design framework, adhering to best practices for identifying, analyzing, and responding to risks. The correct approach represents best professional practice because it integrates risk assessment directly into the design lifecycle, ensuring that potential issues are addressed proactively rather than reactively. This aligns with the principles of secure and resilient infrastructure design, which are implicitly mandated by the need to maintain operational integrity and data availability. By focusing on the impact and likelihood of identified risks, the design team can prioritize mitigation efforts, leading to a more efficient and effective use of resources. This proactive stance minimizes the potential for costly remediation efforts post-deployment and ensures compliance with any implicit regulatory requirements for due diligence in system design. An incorrect approach that focuses solely on identifying every conceivable technical vulnerability without prioritizing based on impact and likelihood fails to provide actionable insights. This can lead to an overwhelming list of low-priority issues that distract from critical risks, potentially violating the principle of due diligence by not effectively allocating resources to the most significant threats. Another incorrect approach that relies on generic, nonspecific risk categories without tailoring them to the specific VMware 6.5 environment misses the opportunity to identify unique threats and vulnerabilities inherent in the chosen technology stack. This can result in an incomplete risk profile and a false sense of security, potentially leading to regulatory noncompliance if specific industry standards or best practices are not met. Finally, an approach that delegates risk assessment entirely to a separate team without active involvement from the design architects creates a disconnect between risk identification and design implementation, making it difficult to translate findings into practical design changes and potentially leading to overlooked risks or impractical mitigation strategies. Professionals should employ a structured decision-making process that begins with understanding the project's objectives and the criticality of the data center environment. This involves defining the scope of the risk assessment, identifying relevant threat actors and potential vulnerabilities specific to VMware 6.5, and then applying a consistent methodology for analyzing the likelihood and impact of identified risks. Prioritization based on a defined risk matrix is crucial for focusing mitigation efforts. The process should be iterative, with risk assessment informing design decisions and design changes being re-evaluated for their impact on the risk profile. Collaboration between design architects, security specialists, and operational teams is essential for a comprehensive and effective risk management strategy. Question 5. The efficiency study reveals a novel method for optimizing virtual machine resource allocation that, while promising significant performance gains, introduces a previously unconsidered interaction with the underlying storage fabric. This interaction has not been documented in the current risk assessment for the VMware vSphere 6.5 environment. What is the most appropriate next step for the data center virtualization design team? Option A. Immediately implement the new resource allocation method to realize the promised performance benefits, assuming the risk is negligible due to the focus on efficiency. Option B. Document the findings of the efficiency study in a separate report and defer any risk analysis until a future, scheduled risk assessment review. Option C. Initiate a formal risk assessment update to analyze the potential impacts of the new resource allocation method on the storage fabric and overall system stability. Option D. Disregard the interaction with the storage fabric, as it is a secondary effect, and the primary goal of the study was VM resource optimization. The correct answer is C. Initiate a formal risk assessment update to analyze the potential impacts of the new resource allocation method on the storage fabric and overall system stability. Explanation. This scenario presents a professional challenge because the efficiency study's findings, while seemingly positive, introduce a new risk vector that was not previously accounted for in the existing risk assessment framework. The core difficulty lies in integrating this emergent risk into a structured and compliant risk management process without compromising the integrity of the data center's security posture or violating VMware's design best practices and the implied regulatory compliance expected in a professional virtualization design context. The correct approach represents best professional practice because it mandates a systematic and documented process for identifying, analyzing, and mitigating new risks. By initiating a formal risk assessment update, the design team adheres to established risk management methodologies, ensuring that the potential impact of the efficiency study's findings on the virtual infrastructure is thoroughly evaluated. This aligns with the principle of proactive risk management, which is crucial for maintaining a secure and resilient data center environment. Furthermore, it demonstrates due diligence and a commitment to informed decision-making, essential for professional integrity in IT design. An incorrect approach that involves immediately implementing the efficiency improvement without a subsequent risk assessment fails to acknowledge the potential for unintended consequences. This bypasses critical security and operational checks, potentially introducing vulnerabilities or performance degradations that could have significant business impact. This constitutes a regulatory and ethical failure by neglecting the fundamental responsibility to ensure the stability and security of the IT environment. Another incorrect approach, which is to dismiss the findings as outside the scope of the current risk assessment, is also professionally unacceptable. This demonstrates a lack of foresight and a failure to adapt to new information that could impact the overall risk profile of the data center. It creates a blind spot in the risk management process, leaving the organization exposed to unknown threats or operational issues. Ethically, it represents a dereliction of duty to provide a comprehensive and up-to-date risk analysis. The professional reasoning process for similar situations should involve a structured approach. First, acknowledge and document all new information or findings, such as those from the efficiency study. Second, determine if this new information introduces any potential risks or impacts existing risk assessments. Third, if risks are identified, initiate a formal risk assessment process, which includes identification, analysis, evaluation, and treatment of the identified risks. Fourth, document all findings, decisions, and mitigation strategies. Finally, communicate these findings and decisions to relevant stakeholders. This systematic process ensures that decisions are data-driven, compliant, and aligned with best professional practices for data center virtualization design. Question 6. Stakeholder feedback indicates a critical business unit requires immediate provisioning of additional virtual machine resources to support a new, time-sensitive application launch. The request is for a significant number of VMs with specific, high-performance configurations that could potentially strain existing storage and network capacity if not carefully integrated. The requesting unit is emphasizing the urgency and suggesting a direct provisioning path to expedite deployment. What is the most appropriate approach for the virtualization design team to take? Option A. Initiate a thorough impact assessment of the requested resources on the existing infrastructure. Engage with IT operations and security teams to validate the proposed configurations against established standards, and present a revised provisioning plan that addresses potential capacity and security concerns while meeting the business unit's urgent needs. Option B. Proceed with provisioning a subset of the requested virtual machine using the most readily available resources, with the understanding that further adjustments can be made post-launch if performance issues arise. Option C. Inform the requesting business unit that their request cannot be immediately fulfilled due to potential resource constraints and advise them to wait for the next scheduled infrastructure upgrade cycle. Option D. Directly provision the requested virtual machines with the specified configurations to meet the urgent deadline, as the business unit has highlighted the critical nature of their application launch. Correct answer is A. Initiate a thorough impact assessment of the requested resources on the existing infrastructure. Engage with IT operations and security teams to validate the proposed configurations against established standards, and present a revised provisioning plan that addresses potential capacity and security concerns while meeting the business unit's urgent needs. Explanation. This scenario presents a common challenge in data center virtualization design, balancing the immediate operational needs of a critical business unit with the long-term strategic goals of the organization, particularly concerning resource allocation and future scalability. The challenge lies in the conflicting priorities and the potential for a short-sighted decision to negatively impact other departments or future projects. Careful judgment is required to ensure that the proposed solution is not only effective for the immediate request, but also aligns with the broader IT strategy and resource management policies. The correct approach represents best professional practice because it prioritizes a comprehensive understanding of the request within the context of the entire virtual infrastructure and organizational objectives. By engaging all relevant stakeholders, including IT operations, security, and other business units, the design team can identify potential conflicts, dependencies, and resource constraints early on. This collaborative process ensures that the proposed solution is technically sound, secure, compliant with organizational policies, and economically viable. It fosters transparency and buy-in, reducing the likelihood of future issues or rework. Adhering to established change management and resource allocation protocols, as would be expected within a regulated environment, is paramount. An incorrect approach that focuses solely on the immediate request without considering broader implications is professionally unacceptable. This could lead to resource contention, performance degradation for other services, security vulnerabilities if not properly assessed, and increased operational overhead. From a regulatory and ethical standpoint, such an approach could violate internal IT governance policies, potentially leading to noncompliance with service-level agreements, SLAs, for other departments, and could be seen as a failure to act in the best interest of the organization as a whole. It demonstrates a lack of due diligence and a failure to consider the interconnectedness of the virtualized environment. Another incorrect approach that bypasses established review processes, such as security or architectural review boards, is also professionally unacceptable. This circumvents critical checks and balances designed to ensure the integrity, security, and scalability of the infrastructure. Ethically, it undermines the established governance framework and could expose the organization to significant risks. It suggests a disregard for established best practices and a potential for unauthorized or poorly conceived changes. The professional reasoning process for similar situations should involve a structured approach. 1. Understand the request, clearly define the business need and technical requirement. 2. Assess impact, evaluate the potential impact on existing infrastructure, other services, security, and compliance. 3. Engage stakeholders, consult with all relevant parties including operations, security, finance, and affected business units. 4. Explore alternatives, consider different design options and their trade-offs. 5. Document and review, thoroughly document the proposed solution, its rationale, and potential risks. Submit for formal review and approval through established channels. 6. Implement and monitor. Execute the approved design and continuously monitor its performance and impact. Question 7. System analysis indicates a need to enhance the security posture of a VMware vSphere 6, 5 data center environment. The primary objective is to protect sensitive customer data and ensure continuous service availability, without specific regulatory mandates dictating a particular risk assessment methodology. Which approach to identifying and prioritizing security risks would be considered the most professionally sound and effective for designing robust data center virtualization solutions. Option A. Focus exclusively on risks that can be easily quantified with numerical data, such as the cost of hardware failure or the probability of network outages, and defer assessment of less quantifiable risks. Option B. Rely solely on the security recommendations provided by third-party consultants who have previously worked with the organization on unrelated IT projects. Option C. Immediately implement all available advanced security features and patches recommended by the virtualization vendor to ensure the environment is protected against known exploits. Option D. Conduct a comprehensive risk assessment that involves identifying critical assets, potential threats and vulnerabilities, analyzing the likelihood and impact of these risks, and prioritizing mitigation strategies based on the assessed risk levels. The correct answer is D. Conduct a comprehensive risk assessment that involves identifying critical assets, potential threats and vulnerabilities, analyzing the likelihood and impact of these risks, and prioritizing mitigation strategies based on the assessed risk levels. Explanation. This scenario presents a common challenge in data center virtualization design, balancing the need for robust security controls with the operational requirements of a dynamic and evolving IT environment. The professional challenge lies in accurately identifying and prioritizing risks that could impact the confidentiality, integrity, and availability of critical data and services, while also ensuring that proposed mitigation strategies are practical, cost-effective, and compliant with relevant VMware best practices and general IT security principles applicable within a typical enterprise context. The absence of specific regulatory mandates for this particular exam means we rely on industry-standard risk assessment methodologies and the implicit expectation of due diligence in professional IT design. The correct approach represents best professional practice because it systematically identifies potential threats and vulnerabilities, assesses their likelihood and impact, and then prioritizes mitigation efforts based on the severity of the risk. This aligns with the core principles of IT risk management, ensuring that resources are allocated to address the most critical issues first. It promotes a proactive security posture, reducing the likelihood of security breaches and operational disruptions. This methodology is universally accepted in professional IT design and aligns with the spirit of responsible system architecture. An incorrect approach that focuses solely on implementing the latest security features without a prior risk assessment is professionally unacceptable. This leads to wasted resources on controls that may not address the most significant threats, or worse, introduces complexity that could itself become a vulnerability. It fails to demonstrate due diligence in understanding the specific threat landscape of the environment. Another incorrect approach that prioritizes only the most easily quantifiable risks ignores potentially high impact, but less easily measured risks such as insider threats or complex supply chain vulnerabilities. This narrow focus can leave critical gaps in the security posture. Finally, an approach that relies solely on vendor recommendations without independent validation is also professionally deficient. While vendors offer valuable insights, their primary objective is product sales. A professional design must independently assess the suitability and effectiveness of proposed solutions within the specific context of the organization's risk profile. The professional reasoning process for similar situations should involve a structured risk assessment framework. This includes defining the scope of the assessment, identifying assets and their criticality, identifying threats and vulnerabilities, analyzing the likelihood and impact of potential risks, evaluating existing controls, determining residual risk, and planning for risk treatment, mitigation, acceptance, transfer, or avoidance. This systematic approach ensures that decisions are data-driven and aligned with business objectives and risk tolerance. Question 8. Governance review demonstrates that the current VMware vSphere 6.5 data center virtualization design has several potential vulnerabilities that could impact service availability and data integrity. The review specifically highlighted a lack of formal risk assessment documentation and a reactive approach to security patching. What is the most appropriate next step to address these findings? Option A. Focus on acquiring new security hardware and software solutions to bolster the data center's defenses, assuming this will inherently address the identified risks. Option B. Immediately implement the latest security patches across all vSphere components without further analysis to address the identified patching deficiencies. Option C. Initiate a comprehensive risk assessment process to identify, analyze, and prioritize potential threats and vulnerabilities, followed by the development of a risk mitigation strategy that includes a proactive patch management plan. Option D. Defer any significant changes to the virtualization design until a future project, as the current infrastructure is deemed stable for immediate operational needs. Correct answer is C. Initiate a comprehensive risk assessment process to identify, analyze, and prioritize potential threats and vulnerabilities, followed by the development of a risk mitigation strategy that includes a proactive patch management plan. Explanation. This scenario presents a common challenge in IT governance, where a recent governance review has identified potential risks associated with the current data center virtualization design. The professional challenge lies in translating these identified risks into actionable mitigation strategies that align with both technical best practices and the implicit regulatory expectations of a VMware certified advanced professional 6.5 data center virtualization design context, which assumes adherence to general IT governance principles and potentially industry-specific compliance frameworks. Though no specific jurisdiction is mandated for this exam, the principles of sound governance and risk management are universal. The need for a structured approach to risk assessment is paramount to ensure that the proposed solutions are effective, efficient, and defensible. The correct approach represents best professional practice because it directly addresses the identified risks through a systematic and documented process. By prioritizing risks based on their potential impact and likelihood, and then developing specific, measurable, achievable, relevant, and time-bound, smart mitigation plans, the design team ensures that resources are allocated effectively to the most critical areas. This aligns with the principles of due diligence and prudent risk management, which are foundational to any IT governance framework. The emphasis on documenting the risk assessment and mitigation strategy provides an auditable trail, essential for demonstrating compliance and accountability. Incorrect approaches fail to meet professional standards for several reasons. Focusing solely on implementing new technologies without a thorough risk assessment can lead to overspending, introducing new, unforeseen risks, and failing to address the root causes of the identified issues. This demonstrates a lack of strategic thinking and a reactive rather than proactive stance. Ignoring the identified risks or deferring action indefinitely is a clear abdication of responsibility and a direct violation of governance principles, potentially exposing the organization to significant operational, financial, and reputational damage. Furthermore, implementing solutions without considering their impact on existing systems or without proper testing introduces further instability and risk, undermining the integrity of the data center infrastructure. The professional decision-making process for similar situations should involve a structured risk management lifecycle. This begins with risk identification, as highlighted by the governance review, followed by risk analysis, assessing likelihood and impact, risk evaluation, prioritizing risks, risk treatment, developing mitigation strategies, and ongoing risk monitoring and review. Professionals must maintain a balance between technical feasibility, business objectives, and risk appetite. Documentation at each stage is crucial for transparency, accountability, and continuous improvement. Question 9. The efficiency study reveals that consolidating several underutilized virtual machines onto fewer, more powerful hosts could significantly reduce power consumption and hardware maintenance costs. However, the study has not detailed the potential impact of this consolidation on application performance under peak load conditions, the increased risk of single points of failure if a host experiences an outage, or the security implications of having more critical services residing on fewer physical machines. What is the most appropriate next step to ensure a responsible and effective design decision? Option A. Immediately proceed with the consolidation to realize the identified cost savings, assuming that any potential issues can be addressed reactively as they arise. Option B. Conduct a thorough risk assessment that quantifies the potential impact of performance degradation, single points of failure, and security vulnerabilities, and develop mitigation strategies before proceeding with consolidation. Option C. Defer the consolidation project indefinitely until a more detailed performance benchmark study can be completed, even if it means foregoing immediate cost savings. Option D. Implement the consolidation for non-critical applications first, and monitor their performance and stability before considering critical applications. Correct answer is B. Conduct a thorough risk assessment that quantifies the potential impact of performance degradation, single points of failure, and security vulnerabilities, and develop mitigation strategies before proceeding with consolidation. Explanation. This scenario presents a professional challenge because the efficiency study, while identifying potential cost savings, has not adequately addressed the associated risks. A core responsibility of a VMware certified advanced professional is to ensure that proposed design changes not only improve efficiency, but also maintain or enhance the stability, security, and availability of the data center infrastructure. Overlooking or downplaying risks can lead to significant operational disruptions, data loss, security breaches, and non-compliance with industry standards and potentially regulatory requirements. Though this exam focuses on design principles rather than specific jurisdictional regulations, the underlying professional ethics demand risk consideration. The correct approach represents best professional practice because it prioritizes a comprehensive risk assessment before implementing any changes. This aligns with the fundamental principles of IT service management and robust system design, which mandate a proactive identification, analysis, and mitigation of potential threats and vulnerabilities. By thoroughly evaluating the impact of the proposed efficiency measures on critical systems, data integrity, and business continuity, the organization can make informed decisions, implement appropriate controls, and avoid unforeseen negative consequences. This demonstrates due diligence and a commitment to maintaining a resilient and secure data center environment. An incorrect approach that focuses solely on cost reduction without a commensurate risk evaluation is professionally unacceptable due to several failures. Firstly, it demonstrates a lack of foresight and a failure to adhere to best practices in system design and management, which inherently include risk management. This can lead to a situation where the perceived cost savings are dwarfed by the costs incurred from operational failures, security incidents, or compliance violations. Secondly, it can be seen as an ethical lapse, as it prioritizes short-term financial gains over the long-term stability and security of the IT infrastructure, potentially jeopardizing business operations and stakeholder trust. Ignoring potential risks also means failing to adequately protect sensitive data and critical services, which could have severe reputational and financial repercussions. The professional reasoning process for similar situations should involve a structured approach to decision-making. This begins with clearly defining the objectives of any proposed change, in this case, efficiency improvements. Subsequently, a thorough risk assessment must be conducted, identifying potential threats, vulnerabilities, and their impact. This assessment should inform the development of mitigation strategies and contingency plans. Finally, a cost-benefit analysis should be performed, not just on the efficiency gains, but also on the costs of implementing risk mitigation measures and the potential costs of unmitigated risks. This holistic approach ensures that decisions are well-informed, balanced, and aligned with the organization's overall risk appetite and business objectives. Question 10. Assessment of the most appropriate strategy for enhancing the security posture of a VMware vSphere 6.5 environment in response to a newly identified critical vulnerability, considering the need for rapid deployment while maintaining architectural integrity and long-term operational efficiency. Option A. Select the least expensive security appliance available on the market that purports to mitigate the identified threat, prioritizing cost savings over detailed technical assessment. Option B. Immediately deploy a proprietary security solution from a leading vendor that claims to address the specific vulnerability, without extensive testing or consideration of its compatibility with other security tools in use. Option C. Implement a custom-built security script developed by an internal team to patch the vulnerability, bypassing standard change control processes to expedite deployment. Option D. Conduct a thorough evaluation of multiple security solutions, including open source and commercial offerings, assessing their integration capabilities with the existing vSphere infrastructure, impact on performance, scalability, and alignment with VMware's recommended security best practices, followed by a phased deployment after comprehensive testing in a lab environment. The correct answer is D. Conduct a thorough evaluation of multiple security solutions, including open source and commercial offerings, assessing their integration capabilities with the existing vSphere infrastructure, impact on performance, scalability, and alignment with VMware's recommended security best practices, followed by a phased deployment after comprehensive testing in a lab environment. Explanation. This scenario presents a professional challenge in balancing the immediate need for enhanced security with the long-term implications of architectural decisions. The core difficulty lies in selecting a security solution that not only addresses the current vulnerability, but also aligns with the organization's strategic goals, operational constraints, and the VMware Certified Advanced Professional 6.5 Data Center Virtualization Design Framework. A hasty, short-sighted decision could lead to technical debt, increased operational overhead, and potential compliance issues down the line. Careful judgment is required to ensure the chosen solution is robust, scalable, and maintainable. The correct approach represents best professional practice because it prioritizes a holistic evaluation of potential solutions against established design principles and organizational requirements. This involves a thorough assessment of the security posture, considering factors beyond immediate threat mitigation, such as integration with existing infrastructure, impact on performance, scalability, and adherence to VMware best practices for data center virtualization. By engaging stakeholders and considering the long-term operational and business impact, this approach ensures a sustainable and effective security enhancement that supports the overall data center strategy. This aligns with the professional responsibility to design solutions that are not only technically sound, but also strategically aligned and operationally viable. An incorrect approach that focuses solely on a vendor-specific, proprietary solution without considering interoperability or broader architectural fit represents a significant regulatory and ethical failure. It risks vendor lock-in, which can hinder future flexibility and potentially lead to higher long-term costs, violating the principle of designing for efficiency and cost-effectiveness. Furthermore, neglecting to assess the solution's compatibility with existing security policies and compliance frameworks could result in a breach of regulatory requirements, such as those pertaining to data protection and system integrity, which are implicitly governed by the need for robust and auditable security designs. Another incorrect approach, which involves implementing a solution without adequate testing or validation in a non-production environment, poses a severe operational and security risk. This failure to adhere to standard IT governance and change management practices can lead to unexpected downtime, data corruption, or security vulnerabilities, directly contravening the professional obligation to ensure the stability and security of the virtualized environment. This also represents an ethical lapse in due diligence, as it exposes the organization to unnecessary risks. Finally, an approach that prioritizes the cheapest available solution without a comprehensive evaluation of its technical merits, supportability, and long-term total cost of ownership is professionally unsound. This can lead to the selection of inadequate or unsupported technologies, compromising the security and reliability of the data center. It also fails to meet the professional standard of designing for resilience and maintainability, potentially leading to future remediation costs and operational disruptions. The professional reasoning process for similar situations should involve a structured approach. First, clearly define the problem and its scope. Second, identify and engage all relevant stakeholders to gather requirements and understand constraints. Third, research and evaluate multiple potential solutions, considering their technical feasibility, alignment with architectural principles, security implications, operational impact, and total cost of ownership. Fourth, conduct thorough testing and validation in a controlled environment. Fifth, document the decision-making process and the rationale behind the chosen solution. Finally, ensure ongoing monitoring and evaluation of the implemented solution. Question 11. Comparative studies suggest that when designing a disaster recovery strategy for a virtualized data center, a critical factor is the alignment of technical solutions with business continuity objectives. Considering a scenario where a company has a diverse range of applications with varying levels of criticality and data sensitivity, which approach to disaster recovery design best exemplifies professional best practice in this context? Option A. Design a disaster recovery solution that relies heavily on manual intervention for failover and failback processes, with infrequent ad hoc testing to validate its functionality. Option B. Prioritize the synchronous replication of all virtual machines to a geographically distant secondary data center to ensure the lowest possible RPO and RTO for every workload, irrespective of its business impact. Option C. Implement a tiered disaster recovery strategy that categorizes virtual machines based on their business criticality, RTO, and RPO requirements, and then applies appropriate replication and recovery technologies for each tier, coupled with regular automated testing. Option D. Focus solely on cost reduction by implementing a basic backup solution with a long recovery time objective, assuming that most applications can tolerate significant downtime. The correct answer is C. Implement a tiered disaster recovery strategy that categorizes virtual machines based on their business criticality, RTO, and RPO requirements, and then applies appropriate replication and recovery technologies for each tier, coupled with regular, automated testing. Explanation. This scenario presents a common challenge in data center virtualization design, balancing the need for robust disaster recovery capabilities with the practical constraints of budget and operational complexity. The professional challenge lies in selecting a DR strategy that meets recovery time objectives, RTO, and recovery point objectives, RPO, without introducing undue risk or cost, all while adhering to VMware best practices and potential regulatory compliance requirements that might be implied by the nature of the data being protected. Careful judgment is required to assess the trade-offs inherent in different DR solutions. The correct approach represents best professional practice because it prioritizes a phased implementation based on a thorough assessment of business criticality and risk. This aligns with industry-standard methodologies for DR planning, which emphasize understanding the impact of downtime on different applications and services. By categorizing workloads and applying appropriate RTO/RPO tiers, the design ensures that critical systems are protected with the most resilient solutions, while less critical ones receive protection commensurate with their business value. This pragmatic approach minimizes unnecessary expenditure and complexity, focusing resources where they are most needed. It also implicitly supports regulatory compliance by ensuring that data protection levels are aligned with business needs and potential legal or industry mandates for data availability and integrity. An incorrect approach that focuses solely on replicating all virtual machines synchronously to a remote site, regardless of criticality, fails professionally by ignoring cost-effectiveness and operational feasibility. This can lead to significant overspending on infrastructure and network bandwidth, and potentially introduce performance bottlenecks for non-critical applications. Ethically, it represents a failure to act as a responsible steward of organizational resources. Another incorrect approach that proposes a set it and forget it approach with minimal testing and validation is professionally unacceptable due to the inherent risk of DR failure. Best practices and regulatory expectations for DR demand regular testing to ensure that recovery procedures are effective and that the implemented solutions function as intended. A lack of testing can lead to a false sense of security, and in a real disaster, the DR solution may not work, leading to catastrophic data loss and extended downtime, which could have severe regulatory and financial consequences. A third incorrect approach that relies on manual intervention for all recovery operations is also professionally flawed. While manual steps might be necessary in some edge cases, a robust DR strategy should leverage automation as much as possible to reduce human error and accelerate recovery times. Over-reliance on manual processes increases the RTO and RPO, making the DR solution less effective and potentially exposing the organization to greater risk. This also fails to meet the expected standard of care in modern IT infrastructure management. The professional decision-making process for similar situations should involve a structured risk assessment, a clear understanding of business requirements, including RTO/RPO for different application tiers, an evaluation of available technologies and their associated costs and complexities, and a commitment to regular testing and validation. This iterative process ensures that the chosen DR solution is not only technically sound, but also aligned with business objectives and risk tolerance. Question 12. The control framework reveals a proposed disaster recovery strategy for a critical production environment that relies on a complex multi-site replication mechanism involving asynchronous data transfer and custom scripting for failover orchestration. While the proposed solution aims to meet stringent recovery point objectives, RPO, and recovery time objectives, RTO, it introduces significant operational overhead and a higher potential for configuration drift. What is the most professionally responsible approach to evaluating and proceeding with this disaster recovery design? Option A. Proceed with the proposed solution, but defer rigorous testing and validation until after the initial implementation to minimize project timelines. Option B. Conduct a comprehensive validation of the proposed solution against VMware's architectural best practices, focusing on simplicity, resilience, and testability, and explore alternative designs that may offer comparable RPO/RTO with reduced complexity. Option C. Focus solely on the cost-effectiveness of the proposed solution, as minimizing expenditure is the primary driver for IT infrastructure decisions. Option D. Immediately implement the proposed solution, as it directly addresses the stated RPO and RTO requirements, prioritizing business continuity above all other design considerations. The correct answer is B. Conduct a comprehensive validation of the proposed solution against VMware's architectural best practices, focusing on simplicity, resilience, and testability, and explore alternative designs that may offer comparable RPO/RTO with reduced complexity. Explanation. The control framework reveals a critical juncture in the data center virtualization design process, where the proposed solution for disaster recovery, DR, introduces significant complexity and potential points of failure. The challenge lies in balancing robust business continuity requirements with the practicalities of implementation, ongoing management, and adherence to VMware's best practices for performance and stability. A key aspect of this scenario is the need to evaluate the proposed DR approach against established design principles and potential regulatory compliance implications. Even if not explicitly stated as a direct regulatory requirement, the underlying principles of data integrity and availability are often implicitly covered by broader compliance mandates. The correct approach involves a thorough evaluation of the proposed DR solution's alignment with VMware's architectural best practices, focusing on simplicity, resilience, and manageability. This includes assessing the impact on the primary production environment, the feasibility of regular testing, and the overall cost-effectiveness. By prioritizing a design that minimizes complexity and leverages native VMware capabilities where appropriate, the solution is more likely to be stable, performant, and easier to maintain, thereby indirectly supporting any implicit regulatory expectations around data availability and integrity. This aligns with the professional responsibility to design solutions that are not only functional but also sustainable and secure. An incorrect approach would be to proceed with the complex DR solution without rigorous validation, assuming that meeting the RPO/RTO targets is the sole criterion. This overlooks the inherent risks associated with overly intricate designs, such as increased potential for configuration errors, difficulties in troubleshooting, and challenges in performing effective DR testing. Such an approach could lead to a system that fails during a real disaster, violating the fundamental purpose of a DR plan and potentially leading to significant business disruption and reputational damage. Furthermore, failure to adequately document and test the DR solution could be seen as a lapse in due diligence, which could have implications if audits or compliance reviews were to occur, even if no specific regulation was directly breached. Another incorrect approach would be to prioritize cost savings over the robustness and testability of the DR solution, potentially leading to a design that is inadequate for its intended purpose. This demonstrates a failure to understand the true cost of downtime and the importance of a reliable DR strategy. The professional decision-making process in such a scenario should involve a multifaceted evaluation. First, clearly define the business requirements for RPO and RTO. Second, explore multiple design options, including those that leverage native VMware features and those involving third-party solutions. Third, conduct a thorough risk assessment for each option, considering complexity, cost, manageability, and testability. Fourth, consult VMware's official documentation and best practices for guidance. Finally, engage stakeholders to ensure the chosen solution meets business needs while remaining technically sound and operationally feasible. Question 13. To address the challenge of designing a highly available virtualized data center with stringent recovery point objectives, RPO, of near zero and recovery time objectives, RTO, of under 1 hour, while also considering cost effectiveness, which storage replication strategy would best align with these requirements for a critical financial services application? Option A. Implement a storage solution that supports synchronous replication between the primary and secondary data centers, ensuring data consistency and minimal data loss at the cost of potentially higher latency for write operations. Option B. Focus on maximizing storage capacity at the secondary site with a direct attached storage (DAS) solution, assuming data can be manually restored from backups within the RTO. Option C. Deploy a tiered storage approach with object storage for backups and a low-cost, high-capacity spinning disk array for primary data, relying on infrequent scheduled replication. Option D. Utilize asynchronous replication with a replication interval of 15 minutes, prioritizing lower write latency at the primary site, and accepting a potential data loss of up to 15 minutes in a disaster scenario. Correct answer is A. Implement a storage solution that supports synchronous replication between the primary and secondary data centers, ensuring data consistency and minimal data loss at the cost of potentially higher latency for write operations. Explanation. The scenario presents a common challenge in data center virtualization design, balancing performance requirements with the need for robust disaster recovery capabilities. The professional challenge lies in selecting the most appropriate storage solution that meets both stringent RPO recovery point objective and RTO recovery time objective targets without introducing unacceptable latency or cost. This requires a deep understanding of storage technologies, their performance characteristics, and their implications for business continuity. Careful judgment is required to avoid over-engineering or under-provisioning, both of which can have significant financial and operational consequences. The correct approach represents best professional practice because it prioritizes a solution that directly addresses the core requirements of the business continuity plan. By selecting a storage solution that offers synchronous replication, the design inherently supports near-zero RPO, a critical factor for minimizing data loss in the event of a disaster. Furthermore, synchronous replication, when paired with appropriate network infrastructure and high-performance storage arrays, can achieve low RTOs by ensuring data is immediately available at the secondary site. This aligns with the principle of designing for resilience and minimizing business impact, which is a fundamental tenet of data center virtualization design and a key consideration for regulatory compliance related to data integrity and availability. An incorrect approach that relies solely on asynchronous replication would fail to meet the near-zero RPO requirement. While asynchronous replication is suitable for scenarios with less stringent RPO targets, it introduces a window of potential data loss between replication cycles, making it unacceptable when near-zero data loss is a business imperative. This failure to meet a critical business requirement could lead to significant financial and reputational damage in the event of a disaster, potentially violating service-level agreements and industry best practices for data protection. Another incorrect approach that focuses only on the lowest-cost storage solution without adequately assessing its replication capabilities would be professionally negligent. Cost is a factor, but it cannot supersede the fundamental requirements for data protection and availability. Deploying a low-cost solution that cannot meet the defined RPO/RTO targets would be a direct contravention of the design objectives and would expose the organization to unacceptable risks. This demonstrates a failure to perform due diligence and a lack of understanding of the critical interplay between storage technology and business continuity. Finally, an approach that overemphasizes raw storage capacity without considering the performance implications for replication and recovery would also be flawed. While ample capacity is necessary, it is meaningless if the underlying technology cannot support the required replication speeds or recovery times. This would lead to a system that appears adequate on paper but fails under the stress of a disaster event, again highlighting a failure to meet the core design requirements and potentially leading to data loss or extended downtime. The professional reasoning process for similar situations should involve a thorough understanding of business requirements, particularly RPO and RTO. This should be followed by an evaluation of available technologies and their suitability against these requirements, considering performance, cost, and scalability. A risk-based approach is essential, where potential failures are identified and mitigated through appropriate design choices. Finally, clear documentation and communication of the design decisions and their rationale are crucial for stakeholder buy-in and future maintenance. Question 14. Market research demonstrates a growing interest in adopting bleeding-edge storage virtualization technologies that promise significant performance gains and cost reductions. A proposed design for a new data center environment includes the immediate integration of a novel, vendor-agnostic storage overlay solution that has only recently entered general availability. This solution has limited documented deployments in enterprise-scale environments and its integration with existing VMware vSphere 6. 5 features like vMotion and DRS has not been extensively validated by the vendor or third-party auditors. The design team is eager to leverage this technology to meet aggressive performance targets. Which of the following approaches best aligns with professional best practices for designing and implementing such a critical data center component? Option A. Integrate the storage overlay solution into the production environment for a limited number of virtual machines, focusing solely on achieving the desired performance metrics and deferring any detailed validation of its resilience or security implications until after initial deployment. Option B. Conduct a comprehensive proof of concept (POC) in a dedicated lab environment to validate the storage overlay's performance, stability, and compatibility with key vSphere 6. 5 features. Develop a phased rollout plan based on POC findings, including rigorous testing of failover, recovery, and security configurations, before considering broader deployment. Option C. Deploy the storage overlay solution on a small subset of non-critical virtual machines to gauge its real-world performance and stability, without performing extensive compatibility testing with core vSphere features, relying on the vendor's claims of interoperability. Option D. Implement the novel storage overlay solution immediately across the entire data center, prioritizing its performance benefits, and assuming that any integration issues will be resolved through vendor patches and ongoing operational adjustments. Correct answer is D. Implement the novel storage overlay solution immediately across the entire data center, prioritizing its performance benefits, and assuming that any integration issues will be resolved through vendor patches and ongoing operational adjustments. Explanation: this scenario presents a common challenge in data center virtualization design, balancing the desire for cutting-edge technology with the practical realities of operational stability and regulatory compliance. The professional challenge lies in evaluating proposed solutions not just on their technical merits, but also on their alignment with established best practices for resilience, security, and manageability, all within the context of the VMware Certified Advanced Professional 6.5 Data Center Virtualization Design exams implied regulatory framework, which emphasizes robust, secure, and auditable virtual infrastructure. The correct approach represents best professional practice because it prioritizes a phased, risk-managed implementation of new technologies. This involves thorough validation in a controlled environment before broad deployment, ensuring that potential impacts on existing systems and compliance requirements are understood and mitigated. This aligns with the principles of responsible IT governance, which mandate due diligence and risk assessment to prevent service disruptions and security breaches. Adhering to vendor best practices and established design patterns for high availability and disaster recovery is also paramount, ensuring the solution meets the demanding uptime and data protection requirements expected in a professional data center environment. Each incorrect approach carries significant regulatory and ethical risks. Deploying unproven technologies without adequate testing or validation directly violates the principle of due diligence. This could lead to unforeseen system failures, data loss, or security vulnerabilities, all of which have serious implications for business continuity and regulatory compliance. Furthermore, bypassing established change management processes and ignoring vendor recommendations demonstrates a disregard for operational integrity and could be construed as professional negligence. The failure to consider the impact on existing security controls or to ensure proper logging and auditing mechanisms are in place for new components also represents a significant compliance failure, potentially violating data protection and privacy regulations. The professional reasoning process for similar situations should involve a structured evaluation of any proposed solution. This includes 1. Understanding the business and technical requirements. 2. Identifying potential risks and their impact on compliance and operations. 3. Researching vendor best practices and industry standards. 4. Developing a phased implementation and testing plan. 5. Ensuring adequate documentation and training. 6. Obtaining necessary approvals through formal change management processes. This systematic approach ensures that decisions are informed, risks are managed, and the resulting design is robust, secure, and compliant. Question 15. Operational review demonstrates a consistent pattern of increased latency and reduced throughput for a critical business application hosted on the virtual infrastructure. Initial investigations suggest potential resource contention, but the exact cause remains unclear. The infrastructure team is considering several immediate actions to alleviate the performance degradation. Option A. Immediately increase the allocated CPU and memory resources for all virtual machines hosting the application, assuming a general resource shortage. Option B. Implement a new experimental network optimization feature across the entire virtual environment without specific testing on the affected application. Option C. Roll back recent configuration changes made to the virtual infrastructure, as these might be the cause, without first identifying which specific changes are problematic. Option D. Conduct a detailed workload analysis to understand the application's resource demands, identify specific bottlenecks, and then propose targeted optimizations based on these findings. The correct answer is D. Conduct a detailed workload analysis to understand the application's resource demands, identify specific bottlenecks, and then propose targeted optimizations based on these findings. Explanation. This scenario presents a common challenge in data center virtualization design, balancing performance optimization with resource constraints and adherence to established best practices. The professional challenge lies in identifying the most effective and compliant method for addressing performance degradation without introducing new risks or violating design principles. Careful judgment is required to select an approach that is not only technically sound, but also aligns with the principles of efficient resource utilization and long-term system stability. The correct approach represents best professional practice because it directly addresses the root cause of the performance issue by analyzing the underlying workload behavior and its interaction with the virtual infrastructure. This methodical, data-driven approach ensures that any proposed solution is targeted and effective, minimizing the risk of unintended consequences. It aligns with the principle of proactive problem-solving and continuous improvement, which are fundamental to maintaining a robust and efficient data center environment. Furthermore, by focusing on understanding the workload, it adheres to the best practice of designing solutions that are workload-aware, rather than applying generic fixes. An incorrect approach that focuses solely on increasing resource allocation without understanding the workload's needs is professionally unacceptable. This is because it represents a brute force solution that can lead to significant cost inefficiencies and potentially mask underlying architectural flaws. It fails to adhere to the best practice of optimizing resource utilization and can lead to over-provisioning, which is a waste of capital and operational expenditure. Ethically, it can be seen as a failure to provide the most cost-effective and efficient solution for the organization. Another incorrect approach that involves implementing a broad, untested optimization technique without prior analysis is also professionally unacceptable. This demonstrates a lack of due diligence and can introduce instability or unforeseen performance regressions. It violates the principle of a controlled and measured approach to system changes, which is critical in a production data center environment. The regulatory and ethical failure here lies in potentially compromising the stability and availability of critical services without a clear understanding of the risks involved. The professional decision-making process for similar situations should involve a structured approach. 1. Problem identification and scoping. Clearly define the observed performance issue and its impact. 2. Data gathering and analysis. Collect relevant performance metrics, logs, and configuration data. 3. Root cause analysis. Systematically investigate potential causes, focusing on workload behavior, resource contention, and configuration issues. 4. Solution design and evaluation. Propose solutions based on the root cause analysis, considering best practices, cost-effectiveness, and potential risks. 5. Testing and validation. Implement and test proposed solutions in a controlled environment before production deployment. 6. Monitoring and iteration. Continuously monitor the system after implementation and iterate on the solution as needed. Question 16. Process analysis reveals that a critical financial transaction processing application is being migrated to a virtualized data center. The application is highly sensitive to downtime and performance degradation. The design team must ensure the resilience and availability of this application within the new virtualized environment. Which approach to risk assessment and mitigation is most appropriate for this scenario? Option A. Focus exclusively on mitigating the most frequent hardware failures within the virtualized infrastructure, as these are the most statistically probable causes of downtime. Option B. Assign the entire responsibility for risk assessment and mitigation to the application development team, assuming they will incorporate infrastructure resilience needs into their application design. Option C. Implement the most advanced and expensive resilience technologies available for all potential failure scenarios to ensure absolute protection, irrespective of cost or complexity. Option D. Conduct a comprehensive risk assessment to identify potential threats to application availability and performance, analyze their likelihood and impact, and develop prioritized mitigation strategies based on business criticality. The correct answer is D. Conduct a comprehensive risk assessment to identify potential threats to application availability and performance, analyze their likelihood and impact, and develop prioritized mitigation strategies based on business criticality. Explanation. Scenario analysis. This scenario presents a common challenge in data center virtualization design, where critical business applications availability is directly tied to the performance and resilience of the underlying virtual infrastructure. The challenge lies in balancing the need for robust risk mitigation with the practical constraints of budget, implementation complexity, and potential impact on application performance. A failure to adequately assess and address these risks could lead to significant business disruption, financial losses, and reputational damage. The inherent complexity of virtualized environments, with their interdependencies and dynamic nature, further amplifies the need for a structured and thorough risk assessment process. Correct approach analysis. The correct approach involves a comprehensive risk assessment that identifies potential threats to the availability and performance of the critical application, analyzes their likelihood and impact, and then develops appropriate mitigation strategies. This aligns with best practices in IT service management and disaster recovery planning, which are implicitly supported by regulatory frameworks that mandate business continuity and data protection. By systematically evaluating risks such as hardware failure, network outages, software corruption, and human error, and then prioritizing mitigation efforts based on the potential business impact, the design ensures that the most critical vulnerabilities are addressed effectively. This proactive approach minimizes the likelihood of service disruption and ensures compliance with any implicit or explicit requirements for service availability and data integrity. Incorrect approaches analysis. One incorrect approach is to solely focus on the most common or easily quantifiable risks, such as hardware failure, while neglecting less frequent but potentially catastrophic events like a widespread cyber attack or a major natural disaster. This failure to consider the full spectrum of potential threats represents a significant gap in risk management, potentially leaving the organization exposed to severe consequences. Ethically and professionally, this demonstrates a lack of due diligence in protecting the business's critical assets and services. Another incorrect approach is to implement overly complex and expensive mitigation strategies for every identified risk, regardless of its likelihood or impact. This can lead to inefficient resource allocation, unnecessary operational overhead, and potentially introduce new risks through complexity. Professionally, this indicates a misunderstanding of risk appetite and a failure to apply a cost-benefit analysis to mitigation efforts, which is a fundamental aspect of responsible design and resource management. A third incorrect approach is to defer risk assessment and mitigation to the application development team without providing clear guidelines or integrating it into the infrastructure design process. This creates a siloed approach to risk management, where the infrastructure's ability to support the application's resilience requirements is not adequately considered. This failure to collaborate and integrate risk management across different IT domains can lead to misaligned expectations and ultimately compromise the overall availability and security of the business service. It represents a failure in professional collaboration and a disregard for the interconnectedness of IT systems. Professional reasoning. Professionals should employ a structured risk assessment methodology that begins with identifying critical business requirements and then systematically maps potential threats to those requirements. This involves engaging stakeholders from both business and IT, understanding the application's dependencies, and evaluating the potential impact of various failure scenarios. The decision-making process should prioritize mitigation strategies based on a clear understanding of risk appetite, cost-effectiveness, and the potential for residual risk. Regular review and updates to the risk assessment are crucial to adapt to evolving threats and changes in the IT environment. Question 17. Consider a scenario where a company is upgrading its data center to vSphere 6.5 and needs to implement a new virtual environment. The project team is under significant pressure to complete the deployment rapidly to minimize disruption to ongoing business operations. The team has procured all necessary hardware and software licenses. What is the most professional and risk-averse approach to implementing this new vSphere 6.5 environment? Option A. Focus on installing the XC hosts and vCenter server, and then proceed with configuring the storage and network infrastructure in parallel with the initial virtual machine deployments, without a dedicated pre-implementation validation phase for these critical components. Option B. Conduct a pilot deployment of a subset of the vSphere 6.5 components in a lab environment to validate core functionality and integration, followed by a phased rollout to production, with rigorous validation at each stage of the production implementation. Option C. Proceed with a full production deployment of all vSphere components, including XC hosts, vCenter server, and necessary storage and network configurations immediately after initial hardware setup, without any intermediate validation or pilot testing. Option D. Install the core vSphere components, XC hosts, and vCenter server, and then immediately begin migrating virtual machines, assuming that storage and network configurations will be addressed as issues arise during the migration process. The correct answer is C. Proceed with a full production deployment of all vSphere components, including XC hosts, vCenter server, and necessary storage and network configurations, immediately after initial hardware setup, without any intermediate validation or pilot testing. Explanation. This scenario presents a professional challenge due to the critical nature of data integrity and the potential for significant business disruption if the implementation of a new vSphere 6.5 environment is mishandled. The core difficulty lies in balancing the need for rapid deployment with the imperative to adhere to established design principles and VMware best practices, which are implicitly governed by the need for robust, secure, and performant virtual infrastructure. The professional challenge is amplified by the pressure to deliver a functional environment quickly, which can tempt shortcuts that compromise long-term stability and compliance. The correct approach represents best professional practice because it prioritizes a structured, phased implementation that includes thorough validation at each stage. This aligns with the principles of responsible IT project management and the implicit regulatory expectation of due diligence in deploying critical infrastructure. By performing pre-implementation validation, conducting a pilot deployment, and implementing a phased rollout with post-implementation verification, the team ensures that potential issues are identified and remediated early, minimizing risk to the production environment. This methodical approach safeguards data integrity, ensures service availability, and demonstrates a commitment to a stable and secure virtualized data center, which are foundational to operational compliance and business continuity. An incorrect approach that involves skipping pre-implementation validation and proceeding directly to a full production rollout fails to identify potential compatibility issues between the new hardware, the vSphere 6.5 components, and existing network configurations. This oversight can lead to unexpected failures, data corruption, and extended downtime, directly impacting business operations and potentially violating service-level agreements. Ethically, this demonstrates a lack of due diligence and a disregard for the potential consequences of a flawed deployment. Another incorrect approach, which focuses solely on installing the core vSphere components without validating the storage and network configurations, ignores critical dependencies. Storage and network are fundamental to the performance and availability of virtual machines. Failure to validate these components can result in severe performance degradation, data loss due to storage misconfiguration, or network connectivity issues that render the virtual environment unusable. This approach represents a failure to adhere to fundamental design principles and a disregard for the interconnectedness of data center components, leading to a non-compliant and unstable deployment. A third incorrect approach, which involves deploying all components simultaneously without any form of pilot testing or phased rollout, significantly increases the risk of widespread failure. If an issue arises during this all-encompassing deployment, it can affect the entire environment, leading to a complete outage and extensive recovery efforts. This lack of controlled deployment demonstrates poor risk management and a failure to implement a robust change control process, which are essential for maintaining operational integrity and meeting implicit regulatory requirements for system stability. The professional decision-making process for similar situations should involve a risk-based approach. Before any implementation, a thorough assessment of potential risks should be conducted. This should be followed by the development of a detailed implementation plan that includes clear validation checkpoints at each phase. Prioritizing pilot deployments for new technologies or significant changes allows for real-world testing in a controlled environment before impacting production. Continuous monitoring and post-implementation verification are crucial to ensure the ongoing stability and performance of the deployed solution. Adhering to established project management methodologies and VMware best practices provides a framework for making informed decisions that balance speed with stability and compliance. Question 18. Comparative studies suggest that while technical performance is paramount in data center virtualization design, regulatory adherence can be a significant differentiator. For a US-based financial services firm designing a new virtualized data center, which of the following approaches best balances technical innovation with the imperative of regulatory compliance, specifically considering frameworks like those overseen by the SEC and FINRA? Option A. Conduct a thorough risk assessment that maps proposed design elements to specific U.S. financial regulatory requirements, engaging legal and compliance teams early to ensure all data protection, privacy, and security mandates are met throughout the design lifecycle. Option B. Prioritize the implementation of the most advanced virtualization technologies and performance-optimizing features, with a plan to address regulatory compliance requirements in a subsequent phase after initial deployment. Option C. Focus on achieving the highest possible compute and storage density to minimize hardware costs, deferring detailed regulatory compliance checks until after the infrastructure is operational and performance metrics are validated. Option D. Rely on the organization's existing IT security policies and general data privacy best practices, assuming they are sufficient to meet the specific regulatory obligations of the financial services industry, without explicit validation against current SEC and FINRA guidelines. The correct answer is B. Prioritize the implementation of the most advanced virtualization technologies and performance-optimizing features, with a plan to address regulatory compliance requirements in a subsequent phase after initial deployment. Explanation: this scenario presents a professional challenge because it requires balancing the technical requirements of a virtualized data center design with the stringent regulatory compliance obligations of a financial services organization operating within the United States. The core difficulty lies in ensuring that the proposed design not only meets performance, scalability, and availability objectives, but also adheres to specific data protection, privacy, and security mandates relevant to financial data. The chosen approach must demonstrate a proactive understanding of these regulatory landscapes to avoid significant legal, financial, and reputational repercussions. The correct approach represents best professional practice because it prioritizes a comprehensive risk assessment that directly maps technical design decisions to specific regulatory requirements. This proactive engagement with compliance frameworks, such as those governed by the SEC, FINRA, and potentially state-specific data privacy laws, ensures that the design is inherently compliant from its inception. By involving legal and compliance teams early, the design team can identify potential conflicts or gaps and integrate necessary controls and safeguards, thereby minimizing the risk of non-compliance. This aligns with the ethical obligation of professionals to act with due diligence and to protect the interests of their clients and the organization by upholding legal and regulatory standards. An incorrect approach that focuses solely on technical performance metrics without considering regulatory implications fails to meet the professional standard. This oversight can lead to the implementation of systems that, while technically sound, violate data handling, access control, or audit trail requirements mandated by U.S. financial regulations. Such a failure constitutes a significant regulatory and ethical breach, potentially resulting in hefty fines, sanctions, and loss of operational licenses. Another incorrect approach that assumes existing security measures are sufficient without explicit validation against current regulatory mandates is equally problematic. Regulations evolve, and what was once compliant may no longer be. Failure to reevaluate and adapt the design to meet the latest compliance standards, such as those pertaining to data encryption, breach notification, or third-party risk management, is a direct violation of professional responsibility. This can expose the organization to significant legal liability and reputational damage. The professional reasoning process for similar situations should involve a multidisciplinary approach. First, thoroughly understand the business and technical objectives of the data center virtualization design. Second, identify all applicable U.S. regulatory frameworks relevant to the industry and the type of data being handled. Third, conduct a detailed risk assessment that quantifies the potential impact of noncompliance. Fourth, integrate compliance requirements into the design process from the outset, rather than attempting to retrofit them later. Fifth, engage legal, compliance, and security experts throughout the design and implementation phases. Finally, establish ongoing monitoring and auditing processes to ensure sustained compliance. Question 19. Upon reviewing the initial implementation phase of a new virtualized data center service, The project lead discovers that the team has encountered unexpected performance bottlenecks during initial load testing, deviating from the expected outcomes outlined in the approved design document. The business stakeholders are urgently requesting the service go live within the week to meet a critical market opportunity. The project lead must decide on the immediate next steps to address this situation. Option A. Halt the launch, conduct a root cause analysis of the performance bottlenecks, and implement necessary design or configuration adjustments before proceeding with any further deployment activities. Option B. Inform stakeholders that the launch must be delayed indefinitely until the performance issues are fully resolved, without providing a clear path or timeline for resolution. Option C. Proceed with the service launch as scheduled, deferring the performance issue resolution to a post-launch maintenance window, and document the known performance limitations for operational staff. Option D. Implement a series of aggressive, undocumented configuration tweaks across the virtual infrastructure in an attempt to mask the performance issues and meet the launch deadline. The correct answer is C. Proceed with the service launch as scheduled, deferring the performance issue resolution to a post-launch maintenance window, and document the known performance limitations for operational staff. Explanation. This scenario presents a professional challenge due to the inherent tension between rapid deployment needs and the imperative to maintain robust security and compliance within a virtualized data center environment. The pressure to deliver a new service quickly can lead to shortcuts that compromise long-term stability and adherence to established VMware best practices, and potentially any relevant data protection regulations that might indirectly influence design choices, even if not explicitly stated in the exam's regulatory framework. Careful judgment is required to balance business demands with technical integrity and risk mitigation. The correct approach represents best professional practice because it prioritizes a structured, phased implementation that includes thorough validation and testing. This aligns with the principles of responsible IT deployment, ensuring that the new virtual environment is not only functional, but also secure, scalable, and maintainable. By adhering to a documented design and implementation plan, the team demonstrates due diligence and a commitment to quality, which are foundational to professional IT service delivery. This proactive stance minimizes the risk of introducing vulnerabilities or operational issues that could have significant downstream consequences. An incorrect approach that bypasses critical validation steps, such as comprehensive performance testing and security hardening, represents a failure to uphold professional standards. Such an approach introduces unacceptable risks of system instability, data breaches, and non-compliance with potential security mandates. It prioritizes expediency over reliability and security, which is ethically questionable and professionally irresponsible. Another incorrect approach that involves deviating significantly from the approved design without proper change control and revalidation introduces chaos and unpredictability into the environment. This undermines the integrity of the design process and increases the likelihood of unforeseen conflicts and performance degradation. It demonstrates a lack of discipline and a disregard for established procedures, which are essential for managing complex IT infrastructure. A further incorrect approach that neglects to document the implementation details and any deviations from the original plan creates a knowledge gap and hinders future troubleshooting and maintenance efforts. This lack of transparency and accountability is unprofessional and can lead to significant operational inefficiencies and increased risk over time. Professionals should employ a decision-making framework that emphasizes risk assessment, adherence to established methodologies, and clear communication. This involves understanding the business requirements, evaluating the technical implications of different implementation strategies, and selecting the approach that best balances speed with security, stability, and compliance. A structured change management process, including thorough testing and documentation, is crucial for managing complex deployments effectively. Question 20. Benchmark analysis indicates that a critical data center virtualization upgrade is being considered to enhance disaster recovery capabilities. The proposed solution involves leveraging advanced replication technologies and geographically dispersed storage. Before proceeding with the implementation, what is the most appropriate course of action to ensure compliance with U.S. federal data protection and critical infrastructure regulations? Option A. Conduct a comprehensive regulatory impact assessment, engaging legal and compliance teams to identify all applicable U.S. federal mandates and ensure the proposed solution meets or exceeds these requirements before deployment. Option B. Implement the upgrade based on the vendor's claims of compliance and focus solely on technical performance metrics, deferring any regulatory review until after the system is operational. Option C. Proceed with the upgrade immediately to ensure business continuity, assuming that advanced replication technologies inherently satisfy data protection and critical infrastructure requirements. Option D. Prioritize the technical implementation and only address regulatory concerns if an audit is scheduled, relying on post-implementation adjustments to achieve compliance. The correct answer is A. Conduct a comprehensive regulatory impact assessment, engaging legal and compliance teams to identify all applicable U.S. federal mandates and ensure the proposed solution meets or exceeds these requirements before deployment. Explanation. This scenario presents a professional challenge due to the inherent tension between rapid technological adoption and the stringent requirements of regulatory compliance within a data center virtualization environment. The need to implement new features for enhanced performance and security must be balanced against the imperative to maintain data integrity, availability, and confidentiality, as mandated by relevant regulatory frameworks. The chosen jurisdiction for this exam is U.S. federal regulations, specifically those pertaining to data protection and critical infrastructure. The correct approach represents best professional practice because it prioritizes a thorough understanding and adherence to the established regulatory framework. This involves proactively identifying potential compliance gaps introduced by the new technology, engaging relevant stakeholders, including legal and compliance teams, and implementing controls that demonstrably meet or exceed regulatory requirements. This aligns with the principles of due diligence and risk management, ensuring that the organization operates within legal boundaries and avoids potential penalties or reputational damage. An incorrect approach that bypasses or inadequately addresses regulatory review poses significant risks. Specifically, failing to consult with legal and compliance departments before deployment could lead to violations of data privacy laws e.g. HIPAA if health data is involved, or general data protection principles under NIST frameworks, security standards, e.g. NIST SB 800-53, or critical infrastructure protection guidelines. This demonstrates a lack of professional responsibility and a disregard for the legal obligations of the organization. Another incorrect approach, focusing solely on technical feasibility without considering regulatory impact, is equally problematic. While technically sound, a solution that does not meet compliance standards is ultimately unacceptable and could necessitate costly remediation or even a complete rollback. This highlights a failure to integrate compliance into the design and implementation lifecycle, a core tenet of responsible IT governance. The professional reasoning process for similar situations should involve a structured risk assessment that explicitly includes regulatory compliance as a key factor. Before any significant technological change, a comprehensive review should be conducted to identify all applicable regulations. This should be followed by a gap analysis to determine how the proposed change impacts compliance. Engagement with legal, compliance, and security teams is crucial throughout this process. Documenting all assessments, decisions, and implemented controls provides an auditable trail and demonstrates a commitment to responsible practice.